Hi, I'm Bill Snow, the Chief Development Officer at Open Networking Foundation. It's my pleasure to introduce Hidetaka Nishihara, an engineering researcher from NTT East. Today, he'll be talking about studying data plane function acceleration in local 5G using open networking technology. Hidetaka, please take it away.
Thank you for introduction. My name is Hidetaka Nishihara from NTT East. I'm an network engineer of our company. I'm so happy to introduce to you our activity. I would like to talk about a study of data plane function acceleration in local 5G using open networking technology. Today's agenda. First, after a short introduction of NTT Group, I talk about our new business and new solution utilizing local 5G and open networking technology. Second, I talk about requirements of telecom carriers in local 5G and future work. Okay, now let's move on to introduction part. This is NTT Group organization. NTT Group is divided by rules. For example, NTT is responsible for group management and basic research. NTT East and West are responsible for regional communications business. NTT Docomo is responsible for mobile communications business and so on. I belong to NTT East, which is residential network operator. I'm in charge of the development and research local 5G system and drawing future network service strategy. Let me give you a little bit of background Japanese market. We provide last mile FTTH service to majority of Japan. Total number of subscribers are around 11 million. Chart is a bit old source, but as you can see, the fiber infrastructure has already been widely developed for quite a while in Japan. This slide shows high-level view of our network. The name is Next Generation Network, but we call this NGN for short. We provide FTTH and other services through the NGN. The network is already more than 10 years old. So far, it has been working well, and we have had FTTH coverage over 90% for a couple of years. Anyone in Japan has freedom to enjoy FTTH services at wherever they desire. Recently, diversification of service requirements and diversification of devices have been progressing. In order to follow these, it is necessary to challenge not only FTTH so far, but also new access networks such as no public 5G, we call local 5G. Okay, in this section, I'd like to talk about new business utilizing local 5G. I will briefly explain about local 5G. Public 5G is provided by mobile network operator, which deploy and operate of large-scale facility nationwide. In local 5G, various entities other than telecom carriers, for example, regional companies, local government, and so on, can deploy 5G systems by themselves. So they deploy and operate dedicated facilities for each regional companies. While the technology of local 5G is gradually progressing, but business development is yet to come. So we would like to develop new business utilizing local 5G as soon as possible. Now we are considering concrete business model leveraging advantage of local 5G with various companies in several fields. For example, agriculture, universities, sports, airports, plants, local governments, and so on. In order to explore a way to create new services adding values to customers, Tokyo University and NTT East established test field, which we call Local 5G Open Lab, for institutions to co-create use cases with Local 5G. Now, I will move on to the next section and talk about new solution utilizing local 5G and open networking technology. The conventional mobile core has been developed for large-scale carriers and characterized by high functionality, high performance, and expensive. But in local 5G, regional companies and local governments provide services to users within a limited range. Therefore, it is not necessary for them to require such high functionality, high performance, and expensive. So there are two issues with conventional mobile core in local 5G. Firstly, mobile core should be lightweight, which implement only required functions. Secondly, we should proceed cost reduction by using generic hardware and open source software. So we propose new solutions based on the issues of the conventional mobile core. The proposed architecture is shown in this figure. First, we deploy lightweight user plane function of mobile core at the edge of regional companies. In order to develop lightweight user plane function, we will use programmable switch. Second, control plane function of mobile core, which is common function, is collectively deployed on the NTT cloud. Using this solution, we can provide added value to customers. For example, in our solution, we can terminate GTP tunnel in regional company area, so we can transfer communication that requires low latency to the MEC server. Actually, we deploy user plane function which encap and decap GTP header by using program switch. So we explain briefly. In our experimentation, we use P4 switch, open source mobile access, which is OpenAI interface, and open source mobile core, which is Next EPC. In our implementation, there are two steps. In first step, we add GTP encap and decap entry, which contain GTP tunnel ID and the source IP address of the users to P4 switch. Second step, after GTP termination, transfer using inner IP address. In this implementation, we can realize encap and decap GTP header in P4 switch. In this slide, we show experimental results of our implementation. Left side of this slide, we show configuration of our experiment. Right side of this slide, we show experimental result. We measured throughput of P4 switch, which deployed GTP NCAP and DCAP program. In our implementation, we can confirm the throughput of wire array 10 Gbps. However, there are some problems such as dealing with abnormal systems. So we will consider it in the future. Next section, we will talk about requirements of telecom carriers in local 5G. In local 5G, many regional companies will deploy smaller mobile infrastructure compared to public 5G. Therefore, there are three requirements of telecom carriers in local 5G. First requirement is that regional companies provide services to users within a limited range, so mobile infrastructure in local 5G should be lightweight and low cost. Second requirement is that we need center-managed mechanism. Regional companies is not telecom carrier, so they may not have enough techniques of development and operation. So we need to support and manage of deploying and operating each regional company. Third requirement is that we need customization for individual requests. It is likely that regional companies will have their own requests, so we need customization that can flexibly meet these requests. Okay, now let's move on to future work and conclusion part. For cost reduction of local 5G, we will deploy and evaluate open source software of 5G LAN and open source software of 5G core. In this section, we introduce the evaluation contents of 5G LAN and 5G core. This is plan of evaluating 5G LAN. Our evaluation target of 5G LAN are open air interface and SD-LAN. There are 3 points of our evaluation. First point is implementation and performance. Second point is interoperability. Third point is maintainability and operability. This is plan of evaluating 5G core. Our evaluation target of 5G core are ESA, Free 5G core, and Open 5Gs. There are 4 points of our evaluation. First point is route control function to make by uplink classifier of UPF. Second point is quality control by slicing function. Third point is multi-stage structure of user plane function. Fourth point is multi-access gateway. This is our schedule. We plan to deploy and evaluate 5G LAN and 5G core this year and next year. We also plan to deploy and evaluate ESA and SD-LAN in our lab. In order to do that, we need ONF cooperation. So we would like to continue to cooperate and discuss with ONF. In concluding my presentation, in order to explore a way to create new services, adding values to customers, we are considering concrete business models, leveraging advantage of local 5G with various companies in several fields. For cost reduction and customization, we study local 5G, especially 5G LAN and 5G core, utilizing open networking technology. If you are interested in our study, please contact us. That's all I have to say. Thank you for your attention.
Thank you, Hidetaka. That was really great. I appreciate you taking the time to do the presentation. I got a few questions, if that's okay with you. First one is that Ether is being built and deployed today as a managed service for enterprises. And we're trying to understand what deployment models there may be. So I'm wondering, how do you think local 5G will be deployed and run? Will it be a managed service offered by NTT, or maybe will you have companies who partner with NTT to provide that service?
Thank you. At first, we think that we will deploy and provide a local 5G system individually for each enterprise. But in the future, we would like to offer managed services. So therefore, we would like to evaluate Ether later.
Okay. All right, good. You provided an example of a function enabled through P4, being the GTP termination. And I'm wondering, are there other P4 functions that you'll be investigating? And what other functions do you think that you'll want to put into these P4 switches?
Okay. In order to measure deploy and in order to measure delay and jitter of our network in detail, we will investigate inbound telemetry in the future.
Yep. Okay. Yep. Makes sense. Okay. And I see you're going to be using both open air interface as well as SD-RAN. I'm a lot more familiar with the SD-RAN side of things. I'm curious, what are some of the differences that you see between open air interface and SD-RAN?
Okay. To the best of my knowledge, at this time, SD-RAN covers CU, DU, RIC, but open air interface only covers CU, DU, not RIC. And SD-RAN will conform to Open Radio Access Network. But I don't know the details of both yet, so I plan to evaluate them. In the future, in addition to SD-RAN and open air interface, we will study other open RAN technology suitable for local 5G in detail.
Okay, good. All right, well, those are the questions I had. I wanted to take a moment to say thank you very much, not only for your time today, but also for the amount of time and support that NTT has put in. NTT has supported both Open Networking Foundation and even prior to that, ON Lab, really since the beginning. And it's been a fantastic collaboration, and we look forward to continued working with you. So thank you very much today.
Thank you very much.